is take a look at some compositions and start talking about domain with them a little bit. So, here's a classic one. Let's say f of x is x squared, and g of x is the square root of x. Okay. Now, what we're going to do is we're going to think about the domain of these once we're done. Okay. So what we're going to do is identify the domains of these original two functions to start with, because that's going to help us out when we're done. So these are two of your 12 basic functions. We just talked about these yesterday. X squared, what's its domain? Careful. Not range, domain. Yeah, everything works. We can put negative numbers in there, right? No problems. What about square root? What numbers can we put into a square root? Actually, say it again. 0, yeah, 0 to infinity, including 0, right? So 0 to infinity. Okay. So, let's do g of f of x. I'll do the notation this way this time. So if we take f of x, put it into g of x. So that's going to be the square root of x squared, which will simplify to what? Just x. Okay, so domain. Here's the trick. The domain is not always just simply the domain of whatever you end up with. So you can't say, oh, x. I know that function. That domain is negative infinity to infinity, so I'm good. You have to be able to, with these domains, you have to be able to take a number, plug it into the first equation, and then take that answer and plug it into the other one. That's how a composition works as well. So think of it this way. Since it's f or g of f of x. So if I took a number, I have to be able to put it into f of x, and then take that result and put it into g of x. Okay? So, I can put any number into f of x that I want, right? Okay? And the result will always be what? Positive. And I can take any positive number that I want and put it into a square root, and I'm still good, right? So, starting at the beginning of that whole process, which numbers can I choose then and have it work? Actually, I can do all of them. I can still do all of them because all I need is the result of this first one to work in the second one. Okay? The output of x squared needs to work into the square root of x. Okay? Because the output of this becomes the input of this. Okay? That's kind of the chain that we're going through right now. So because x squared always gives you something that's non-negative, and anything non-negative is good to go in a square root, the domain ultimately is negative infinity to infinity for this one. Now, there is kind of a trick you can use for that where you don't have to necessarily think that through all the way like that every single time. Though it is good to do that because then you really are seeing what's going on. But what you can do instead is just take a look at this right here, square root of x squared. If you analyze the domain of that before you've simplified anything, it'll work. Okay? So think about this. What numbers can I put into this and have it work? Anything. Anything works right there. So your domain is anything. Negative infinity to infinity. It's going to be a little bit more apparent in the next one. What if we go f of g of x? Turn off your phone. F of g of x would be the square root of x squared, which simplifies to x. Now, let's play this same game again with the domain. I'm starting with g of x. Starting with the square root. So, I have a number to begin with that's going to work here first. What numbers work in g of x? 0 to infinity. Okay? So, I'm already locked into that. Has to be 0 to infinity. Okay? And the result of that, I have to be able to square, which I can square whatever I want. So, what should be the domain then? 0 to infinity. Right. Because I have to be able to use those initially. So, again, take a look at this step right here before I've simplified it. Okay? Think domain of this. You see a square root in that problem, right? So you got to think domain of the square root. That's going to do it. Okay? So 0 to infinity. Okay? So, like I said, if you're a little confused about trying to follow the whole process, just go here. Just go right there and it'll work. But it's kind of interesting to look at this where you've got two compositions that come out to the same thing, right? X, yet they're technically different. This composition gives you x where it's the entire graph of x. It looks just like the identity function. It's the whole thing. Actually, it would go this way, right? The entire identity function. This result is actually a ray. It's not a line, right? It's the equation y equals x. Half of it starts at 0 and then goes. Okay, so the first composition makes a line. The second composition makes a ray. All right, and so that's why these can be a little bit challenging, is because you can't just look at the result and assume that that's what it's going to look like. Sometimes it's just a piece because the domain gets in the way. So, all right, let's try some other ones. So how about we'll do f of x equals the natural log, and g of x will be e to the x plus 5. Okay, so let's talk domain of each of these first. What's the domain of the natural log? Yeah. Okay, so 0 to infinity, not including 0 then. What about e to the x plus 5? What's the domain of that? Thanks. Say it again. Negative 5 is actually still good. Remember, the only three things where we could have problems is when we divide, it's when we have a square root, and when we have a log. If you don't have one of those three things, it's always what? Negative infinity to infinity, because everything should still work. Negative 5 in this one, in particular, if you plug that in, you would have e to the 0, right? What's e to the 0? 1. So you still get a result, right? Still works. So negative 5 isn't a bad number for this one. Okay, so this domain, because it doesn't have one of those three kind of red flags going on, negative infinity to infinity. That's still everything. Okay, so let's try some compositions here. F of g of x. So we're going to dump g into f. So the natural log of e to the x plus 5. Can we simplify that? You guys remember that from Algebra 2? Yeah? Yeah, and so it would make just what is the answer here? X plus 5. Right, it's just x plus 5. Okay, so we got that. Can we identify the domain of that thing, though? So again, go back to before you simplify it. Ignore the natural log for right now. In right here, what numbers can I plug in for x into the e to the x plus 5? Anything, right? Everything still works. Now, When I plug in to an e to the x plus 5, the result is always going to be what? The output of an exponential is always what? Positive. Okay? So I've got a positive number for sure. Not even 0. Can't even be 0. Has to be positive. Okay? Can I do a natural log of that? Yes. Yes. No matter what, right? So what's the domain? Yeah, it's technically negative infinity to infinity. Okay? Because of that e, it's going to turn it positive, so it's always going to work. So any number would be okay still. Okay? But again, if you want to just go to that step before things get simplified, try out the domain of that. You can do it that way too. Okay, g of f of x, that's going to be e to the natural log x plus 5. Can we simplify that? This is going to be a little bit of a stretch probably for most of us because it's been a while since we've really looked at properties of logs and exponentials, but maybe we can come up with it. What? You can, but you got to do one step first. Well, I'll help you. I'll get you started here. How about if you have a plus in your exponent, you can turn it into a multiplication problem. So this is e to the natural log x multiplied by e to the 5th. Okay, don't worry about knowing that property for right now. This is just, it happened to pop up in this example, but in general, you're not going to need to know it yet. Okay, but kind of knowing that now, though, what does this simplify to then? Yeah, x times e to the 5th. And e to the 5th is just a constant, right? It's just a number. Okay? If you really wanted to write it as a decimal, I suppose you could, and just leave it as that decimal times x. But that's what it is. Okay, so then what is the domain of this? Can you plug in anything at all? Like the last one? Look at your starting point. Before you simplify anything, right here. Yeah. Right, the first thing you're going to do is take a logarithm, right? When you plug that number in, the very first thing you have to do is take care of this log. And this already has a restriction on it, right? You can only use positive numbers in logs. So, right away, I'm limited where I can only do positive numbers. And from there, everything else is fine. But I gotta stick to that, only positives. So this domain has to be 0 to infinity then.
Wouldn't you come to like -4 because you have that positive 5 there?
It's not, the x plus 5 is not in parentheses. It's the natural log of the number you choose, and then that result plus 5. Yeah. So 0 to infinity is going to be the domain for that. Okay, let's do one more of these together.